So what are isotopes? So first we're going to do this the common sense way just to make sure we really understand the concept, and then we're going to try to come up with an easy to remember simple definition that we can always use because typical science definitions are just too long. So isotopes are different forms of the same element. Different forms of the same element. Take for example the very first element of the periodic table, hydrogen. So most times when we think of hydrogen, we think of it having one proton and no neutrons and a little electron here. And since the proton and neutron numbers combine, or amounts combine to give us the mass number, 1 plus 0 is 1. This has a mass number of 1, and this is how we think of hydrogen. But this is only one kind of hydrogen, one form of hydrogen, and there are 3 different kinds. So this one we call protium, P-R-O. Take note of this prefix here. The second form of hydrogen, it goes like this. It has 1 proton and 1 neutron. Little electron here. So 1 plus 1 is equal to 2, so it has a mass number of 2, and thus we call this one deuterium. Take note of the DU2. And last but not least, we have another one proton, and by now you've probably seen the pattern. It has 2 neutrons, a little electron there. So 1 plus 2 is equal to 3, so this one has a mass number of 3, thus we call it tritium. Tri-3. So now you may be thinking to yourself, like, these look a little different, like they have different numbers of neutron and different mass numbers. How are they the same element? Well, remember that every single atom, every element gets its identity from its proton count. So it's the protons that determine the kind of element that it is. And since all of these are all having 1 proton, they are all hydrogen atoms, just different kinds of hydrogen atoms. So we call them isotopes of hydrogen, just different form of hydrogen, but they're all hydrogen because they have the same proton count, right? The good news is that you don't have to worry too much about the different forms of most of the elements, because most times when we're talking about hydrogen, we're talking about protium. Most times this one is the most abundant one in nature. It accounts for 99.985% of all naturally existing hydrogen atoms. So unless tritium or deuterium is stated clearly, we're most likely talking about protium when we refer to the hydrogen atom. So don't be overwhelmed. So now that we understand what isotopes are, just the different forms of the same element, the neutron number is different, and thus the mass number is different since the neutron number contributes directly to the mass number. Let's try to come up with a definition of isotopes. Okay, so this is what I came up with, and I asked chat to help me verify that it was correct, which it was. So isotopes are variants of an element characterized by differences in neutron count. Pretty simple, pretty straightforward. Variants of an element, so the same element, and they're characterized by differences in neutron count. Chat wanted me to talk more about the fact that the mass number is different and stuff. I didn't think that was needed, because if the neutron number is different, obviously the mass number would be. But if it makes the definition more complete, then it's important to note. So the revised definition is: isotopes are variants of an element characterized primarily by differences in neutron count, resulting in different mass numbers while having the same number of protons and electrons. So it's a little longer, but it definitely covers it. I'd say if you needed a definition for like the answer to a question, definitely the second one because it says more. But if you just want something to keep in the back of your mind to always have the concept, I'd use the first one. The aim is for the definition to clearly paint a picture of the structure in your mind. So 3 key points from the definition is that they are variants of the same element. They're the same element. So if they're the same element, you think of what makes an element, the proton. That's 1. So you think of the proton when you look at the fact that they're the same. Number 2, we talked about the fact that they have different neutron numbers. And consequently, if the neutron numbers are different, then the mass numbers, number 3, are going to be different. So you're thinking about protons and neutrons and the mass numbers. And of course, the electron count is going to be equal to the proton count, unless the element had lost or gained an electron. In its unreacted regular normal state, electron count is equal to the proton count. Now let's try one more. Since we are sure we've got this, we have a clear understanding of what isotopes are. Let's think of one more. Let's use carbon. So carbon is like that perfect atom, so perfect that we use it to get the standard for the mole. So carbon has 6 protons. Most times, again, when we think of carbon, we think of the fact that it has 6 protons and 6 neutrons. And 6 plus 6 gives you 12, so it has a mass number of 12. But again, this is only one form of carbon, and there are 2 types. So this one is carbon 12. Again, most times we just say carbon because this is the most commonly occurring one, like we talked about earlier with protium. But there is another type of carbon that I'd like to talk about, 6 protons, and this one has 8 neutrons. So 6 plus 8 gives you 14. So this one has a mass number of 14, and thus we call it carbon 14. This one is used for dating, when they find like the mummies and the old time things that they dig up. Because it's radioactive, they use it to try to figure out like how long ago was this thing living and stuff like that. So isotopes are fun, they're cool, they're very interesting and not hard. So bonus, now that we've understood a lot about isotopes, I'm just going to share this bonus tip with you. So one of the things that I use to help me grasp concepts in science is understanding words. So most times the name of something kind of defines what that thing is, and you can access that definition if you know how to read the word. And we do this by looking at prefixes, suffixes, and the root words. For example, we talked about the 3 isotopes of hydrogen: protium, deuterium, and tritium. Well, interestingly, the entire word is based off of the Greek word. So the protium gets its name from the Greek word protos, which means first. Deuterium gets its name off the Greek word deuteros, which means second. Interesting fact, this is also how the biblical book of Deuteronomy gets its name, meaning second law. And tritium gets its name from the Greek word tritium, meaning third. And this also tells of their abundance in nature. So protium first, deuterium second, tritium third, and you get the numbers coming out. So that also helps. Let's look at the whole terminology of isotopes. So as you remember, iso, this prefix, means same, and you probably saw that when you were doing like osmosis and diffusion, isotonic solution, hypertonic ice, same, equal. This actually comes from the Greek word isos, which means equal. I could just use the equal sign, which means equal, right? And tope literally just means place. So equal place. So that's saying that these, when you think of isotopes, think of the fact that these have equal place in the periodic table. They are the same element. The only thing that's different is their neutron number, and consequently the mass number, since that's directly influenced by the neutron number. And I know you might be thinking, isn't that more work? But the reality is that science is really repetitive. So if these terminologies are always going to be recurring with different things. So if you have a good understanding of them, then when you come the next time, you can be like, oh, I know what that is. Yeah. Hope this video helped you. Leave in the comment the name of an element with an isotope separate from hydrogen and carbon. And also you can leave if there are any other terms that you'd like for us to talk about. Thank you.